Hello everyone. Today we will be installing Ubuntu 1804 server with btrfs file system and data partition encryption. For edit points, we will be doing this with two hard disks and we will use btrfs as RAID 1. We'll be doing this on VirtualBox since it's fast and simple to set up for these kind of demos. If you don't know VirtualBox, now is a great time to also see it in action. Now, before we start, I'd like to just highlight what we'll do with the encryption. Some people opt for full hard disk encryption, but the problem with that is if the server reboots, you must physically access it in order to enter the encryption password for the boot to proceed. This might be a bit difficult if the server is remote, or if you're hosting your own server, but you're nowhere near it when there's a power cut. As such, it is much better to install your operating system on a partition without encryption and add an encrypted partition or partitions for your data mounts that you want to secure. Since btrfs allows for sub-volume mounts, something you'll see later in action, we will need one partition for encrypted data, which we can then divide and mount in different places. Don't worry if it doesn't make sense yet, it will over the next few videos. I will show you places where you can set up things differently should you decide not to use encryption or should you decide not to use RAID. I mean, you want to keep everything unencrypted and basic. So starting, first let's go to www.ubuntu.com and download the ISO. We will click on download, choose under Ubuntu Server 1804 LTS, being the latest at the time of recording this. And you'll want to download this ISO. I'll cancel this at the moment because I already downloaded it. Now off to VirtualBox. We will create a new virtual machine for this demo. Demo 101. Linux, Ubuntu 64-bit. Since I want all my setup to proceed rather fast, I'll give it 4 gigs of RAM. Let's go wild. 8 gigs of RAM. We'll create a new virtual hard disk now. Type VDI with dynamically allocated space, and we will give it say exactly 60 gigabytes. Before we start, we're going to go into settings and under system, I will give this 4 processors instead of just one, which will make installation much faster. And oops, we also need a second hard disk. And back into settings, under storage, you'll find that we have one controller and there's an attached disk to it, and we can add another disk. Create new one, VDI, dynamically allocated, disk 2 for like better naming, it's exactly 60 gigabytes as well. I should mention you don't need exactly the same amount of disk space on both disks for btrfs RAID 1 to work. It is capable of handling disks of different sizes. Right, now that we're ready, let's start up the virtual machine, which should have theoretically asked us for CD mount, which it doesn't. If it does not ask you to automatically to mount an installation disk, you can go back to settings, storage, and mount it yourself. This is the live server that we'd be downloading. Click OK and click Start. Now, unlike Ubuntu 16.04 and 14.04 installation, which we're using the standard Debian text-based installer, Ubuntu 18.04 has got a new installer type, which you may or may not like, depending on how much you like black background against blue background, I guess. Functionality is very similar. There's a few things you can't do with the new installer. You can, for example, set up full disk encryption, but we're not doing that anyways. I'm going to select language English and change my layout into English UK. My keyboard variant is Macintosh. Adjust to your own settings. We're going to install Ubuntu. Now at this stage, if you got more than one interface, if you need to set up bonding, anything like that, this is where you do it. I'm going to keep it as DHCP, single interface. No proxy required here. Keep a standard mirror for downloading. And this is where we have most of the fun during installation. We're going to choose manual. You'll notice there's two disks which are under available devices. These are the disks that we'll be configuring. We could create standard software rate MD, but we're going to rely on btrfs for that because I like it. btrfs is much more flexible in that. So let's set up the first disk. Like I said, we're going to have two partitions, one that's unencrypted, one that is encrypted. In case you only had one disk, installation would proceed exactly the same way because we set up RAID only after we booted the OS. So first hard disk, we press enter, add a partition, and in this case I'm going to give the host operating system 20 gigabytes. Configure to your own liking. We're going to go with btrfs file system mount point /. So this is our root file system. So we got / root file system btrfs. It's a used device. You'll notice that two partitions were created. Partition 1 being of type BIOS grab and partition 2 being 20 gigabytes. We'll want to do exactly the same thing on the second hard disk except for partition 2 because we're not doing that right now. While we're here, let's set up second hard disk. I wonder if the new installer allows that. We can't set up BIOS grab from here. Well, that makes it easier for us. We're just going to leave it as that. We're configuring first hard disk, automatically added BIOS grab, and we're partition 2 being btrfs mounted as /. Like I said, this is an unencrypted partition. This is where we keep our operating system. After the install has finished and we boot it into a full system, we will be adding the second hard disk into the configuration. On the second hard disk, we'll do exactly the same thing. We'll create two partitions like in this one. We'll install grub on the second hard disk as well. And we will create a btrfs partition. And then we will join them as btrfs RAID 1. After we're done, we're going to create a second partition on each of the hard disks, join it with RAID and with encryption. All that will be done from the operating system. So basic configuration here, partition 1 automatically created with BIOS grub type, partition 2, I'm going to give it 20 gigabytes mount as /. Only on the first hard disk. There's nothing much we have to do here right now. Second continue, we'll begin the installation process, which is exactly what we want to do. Demo. And we're almost done. This will ask if we want to install anything else. We don't at this stage. And all that's remaining is waiting. And now we see that everything was installed. We can give a look if we're so inclined, but I'm just going to go for reboot now. Please remove installation medium percenter. We're going to do that, just that. Under devices in VirtualBox panel, there's going to be optical drives, and we click on remove disk from virtual drive. And we press enter. Yay, this is going well. Installation proceeded and succeeded, but we can't boot. VirtualBox hates me. This is setup port 0, setup port 1. You'll notice that what Ubuntu has called the first disk is actually the second disk. So this one has actual size 2 gigabytes, this one has only 2 meg. And VirtualBox is trying to boot from the first disk, the demo 01, which is why this has happened. What we can do is just change setup ports. There's going to be setup port 1, and this is going to be setup port 0. And now we should be booting from the correct disk. That should in no case be a problem for yourself when you're dealing with real hardware, where the BIOS will actually know where it's at. And if we manage to start, you're welcomed by a cloud init screen, which we were going to completely ignore. Going to log in, jump to root, and install OpenSSH-server in case it's not installed. Well, it is. Great. So we'll SSH into the box now and do everything else from an SSH console, just because terminal is so much better than dealing with this console. Under devices, network settings in VirtualBox, we can set up port forwarding. In advanced, port forwarding, and the host port, let's say 3333, into guest port 22, which is SSH port. What this does is sets up the local host on my host system, port forward into a guest port. So if I now try to connect to port 3333 on my actual physical machine, this will redirect to port 22 on the guest. Right, into the terminal, SSH port 3333 into demo at localhost. To all needs and requirements, this has worked. I'm going to jump into root here. And the first thing we'll do is apt-get update, apt-get dist upgrade. Let's get up to speed with the packages while we are on a fresh system. At this stage, I see it's installing a new init ramfs tools. So after that update, we'll probably want to reboot. But before we do, let's install cryptsetup, which is already installed on this distro, which is excellent. So let's reboot into new ramfs tools. Excellent. Log back in. And since we'll be dealing with the file systems, pretty much every command will have to be done as root anyways. So now that we're ready, we will configure btrfs on the second hard disk. A few useful commands: we can do btrfs file system show /. We see that it's a single hard disk. From this point, we will configure RAID, we'll configure encryption on second partitions, and we'll set everything up. Right, had my coffee and got my voice back, so let's continue. We're going to go to /dev/sda, which is our first hard disk. We're going to show units in bytes, and we're going to print our partition table. Now we're going to replicate exactly the same partition on /dev/sdb. First, we make label GPT because the first hard disk partition table is GPT. We're going to stick to GPT here. Confirm if you're asked if you're sure you want to lose all the data. Print shows no partitions. Excellent. Now we can create them. mkpart, the partition, switch to byte units, mkpart, which asks for start and end. Do excuse me, primary. It's a primary partition. And if we print, we'll see that it starts at 7.6, finishes at 5.1, and is exactly the same size. So now we're going to, let's name it grub, partition number 1, name. We're going to also set partition 1 type to BIOS_grub, which is a special type of partition for booting. And now we'll create a second partition, mkpart primary, starting here and ending here. So we've got the second primary partition, and now we can use btrfs tools to join these partitions into RAID volume. So let's quit. At this stage, we can have a look at fs tab as suggested. You'll notice that / uses UUID, which is excellent because two disks, but they share the same UUID if they're using RAID. So we've got one device, btrfs file system show / single device SDA2. Now we're going to add another one. So btrfs device add /dev/sdb2, and we have to say where, and where is a mount point. So we're mounted a /, And into that /mount point, which is also visible here in fstab, we're adding def sdb2. Nice and simple. Let's have a look at the file system. Now you see that we have two devices. They are not using RAID yet. At the moment, they're automatically striped, so RAID 0. We're using 4 GB on SDA2, 0 GB on SDB2, as you would be expecting. Now we will convert this to RAID 1. Yes, we do everything on the fly with btrfs, which is awesome. btrfs balance start, which will start balancing the partitions, and btrfs has data and metadata. Each one can be in any RAID configuration. We're going to do data convert into RAID 1 and metadata convert into RAID 1. And we want to do it on the /. At this stage, the balancing starts. The / file system is now being changed into RAID 1. That's done. Let's do btrfs balance status. Balance status minus v/ to show where from. There's no balancing, so everything got balanced already. That was quick. btrfs file system show. And now we can see that we're using two disks. They're exactly the same size used because they are in RAID 1. So btrfs RAID 1 setup. That was nice and simple. Still, we can't boot from disk 2 because we need to grab install. Grab install /dev/sdb. Now we can boot from the second disk. Without grab installed, there would be no bootloader on secondary disk. If you want, you can reinstall it on defsda1 as well. On defsda, sorry. Doesn't hurt. Now, if you lose a disk, you still won't be able to boot. The reason for that is that this /btrfs, if it's in a degraded mode, it will refuse to allow you to boot into it because you should know something's wrong, replace disks, perform maybe offline maintenance. This is not what we want. In a remote system, we still want it to be able to boot, and after replace disks, then we want to fix it. As such, we'll add a boot option. In etcfs tab, boot options are defaults, and we're going to add another one called degraded. This will allow us to boot even if we have only one disk, which would be visible, mount -a to remount. Here, but we'll have to reboot first. So we're all set up. We can mount in a degraded system with btrfs. We can boot from one disk, from the other disk. We can boot from both, from any disk if the other one isn't present and is missing. And now we have a system that supposedly should be able to withstand disk loss and has btrfs setup. Except that it won't. See, the problem is by the time we get to fstab, it's too late because we'll have to have /disk mounted. So it's a catch-22. There's a workaround for that. If we edit etc grab.d 10 Linux, this is where grab builds its configuration from. We will find grab command line Linux, which is this line, grab command line Linux. Notice root flags equals subvolume, being root subvolume. This is standard configuration, except that in root flags equals, we will add degraded, comma. Now if we need to boot, it will boot in degraded mode. Everything uses the default, which is excellent because we only need to configure one. We save the file after we made a single line change. And now we just need to configure grep or reconfigure. Or to be exact, I just remembered, it's update grep. Grep has updated. Now it will be using the new configuration with the degraded option. So with all intents and purposes, we shall be able to reboot and it should boot now. So would be nice if that happened. Yay, success. So far so good. Let's create a second partition and encrypt it and put btrfs on it. Jump back into root, nope, we're gonna use parted now. Again, parted/dev/sda, print what we have now. We're going to mkpart, make partition. If we switch to byte units, it will be more accurate. Print mkpart, and this one will start from where this one finishes, plus 1 byte, so 32. And we want it to occupy the rest of the hard disk, so for end we specify -1. This basically means fill the rest of the hard disk. I've done exactly the same mistake again. Let me cancel that. Partition type primary. And parted no longer allows that. Well, this was going well until now. Instead we can do print free, which shows us free space. Make part primary again, which is going to be from this sector all the way to the last one. This byte all the way to the next last one. Now we got 3 partitions, exactly aligned as they should be. Let's do the same thing with SDB. Make primary partition, starting here and ending over here. And the partition is there after we print. Right, we've got the 2 partitions, so we can see we got SDA and SDB3, which are the new partitions we created. Now we'll want to set up encryption on them. You can skip this step if you don't want encryption. Then again, if you didn't want encryption, you would have created the main btrfs file system as a full-sized one. So this is rather simplistic. cryptsetup -v looks format. This tells cryptsetup to format the device. /dev /sda3 and sdb3. Would be nice if we could do both at the same time. So, uppercase yes. One disk at a time. We enter passphrase. I'm going to call it demo. SDA3 is now created. We're going to do the same thing with DB3. Uppercase yes. Again, password is going to be demo here. And we got both disks. So standard way, cryptsetup looks open. And then we give it the device and the name. So since we don't want to be doing that too much, we're going to create a script under user local bin mount encrypted. Hashbang /bin/bash. And cryptsetup looks open /dev/sda3, and the name we're going to give it will be disk1. Cryptsetup looks open /dev/sdb3, and we're going to call it disk2. Nice and simple. We're going to save and run this script for now. Don't forget to change it to make it executable. And let's run it. Enter passphrase for the first disk. Enter passphrase for the second disk. And that's it, you don't get any cool output. What you will get is in dev mapper, your disk 1 and disk 2. These are your disks that you access. SDA3, SDB3 are encrypted versions. You don't touch them from now on. All you do is you mount them. So now what do we do with disk 1 and disk 2? Well, let's do something cool. Let's actually create a file system. That we can achieve with mkfs directly. So mkfs btrfs, type RAID1 for metadata and data. And we're going to use dev mapper disk1 and dev mapper disk2, which is the presentation of the unencrypted version of those disks. And that's done. We now have a btrfs RAID1 with its own UUID. Let's create a directory in / call it /data. And we can now mount /dev/mapper /disk1 or disk2, doesn't make any difference whatsoever which disk, into /data. btrfs subvolume show / shows us subvolumes, but because we are on a completely different file system, the subvolumes are different. So we'll play with subvolumes much later and you'll see what they are for. At the moment, let's do btrfs file system show, command we know already in / sda and sdb2, and /data is our mapper disks, 40 gigabytes in size each. 2 is being pre-allocated for the metadata. So one more thing. Let's edit the mount encrypted file now. We'll add our mount command. And now our mounts will work. Yay! Why aren't we adding this script to boot time? It's because of the encryption. As I stated, it will ask for username and password. So, worst comes to worst, if your server reboots unexpectedly, something you didn't want, you log in and you run this. This file will run your crypt setups, asking for password on both attempts, and will then mount your disk into /data. This will allow you to successfully reboot without having to be there in front of the machine, which is exactly what we wanted to achieve. This at the moment will complete the demo. We are fully set up with everything that was required. btrfs is happy. Degraded mode is something you may want to use at some point, but for that data disk you probably want to know if something goes wrong. But should you ever find yourself in a position where one of the disks is missing, you do -o degraded. And that's about it. Now, if we look at the disks dev SDA3 and SDB3, they are fully encrypted. Your data is safe. Typically, you'll want to use this kind of setup with virtualization, either kvm and livbirt or with LXC containers. This will allow you to mount subvolumes of that encrypted btrfs volume into those places. Everything will be encrypted, but we will cover that in future videos. Thank you very much for watching.